Heron and Riverside Scholars, and welcome back to class. I hope you had a wonderful fall break, and today we're going to jump in and start Unit 3. As your teacher should have discussed, we're going to do things a little bit different this quarter, see how it works out, and we welcome your feedback, of course. So as you can notice, this is no longer an Edpuzzle. Instead, we're going to try a YouTube video with notes to follow along with. So right now you should have the Google Doc opened up and ready to take notes. You can take notes on a separate sheet of paper or type them into the Google Docs. There will be some spots that you do need to draw pictures. So make sure you are drawing pictures somewhere so that you can make sure to get all the information down. So title your, or at the top you should see Unit 3 notes, and this is the start of nuclear chemistry. So our first idea is we're going to look at an atom. So prior to fall break, we talked about the history of the atom and how it came to be and how we have taken evidence and learned more and more about the atom throughout. And so this atom that we're looking at here is an atom of helium, and a lot of different people's ideas were brought together to give us this picture of what one single helium atom might look like. And here it is here. So in the middle, of course, we have the protons and neutrons, and you saw a very similar picture to this in physics if you were at Heron or Riverside. So hopefully you remember it. But in the center, like I said, there's the protons and the neutrons. This is called the nucleus. Our protons are represented with the plus sign, and our neutrons the 0. And then we have an orbital or a shell around it. That word can be used, either one of those words can be used. And then we have electrons on the outer shell. And what we're going to be talking about today is if we look at helium, we see that on the periodic table of elements, it has an atomic number of 2, or it has 2 protons, and we'll look at this in a second. But so since it has 2 protons, if it's neutral, it will also have 2 electrons. And we will continue looking at this throughout. So we talked some about subatomic particles, and again, you saw this slide in physics. Our different subatomic particles we can talk about are protons, neutrons, and electrons. Our symbol for protons will always be a P+. It has a charge of +1 and a mass of 1 AMU. And then a neutron has this symbol, a charge of 0, and the mass is also 1. So our mass for an atom is the protons and the neutrons because the electrons have a very, very small mass that is so small we just use 0. The electron symbol is E, then a little minus, and the charge is -1. Notice again that a neutral atom will have the same number of protons as electrons because those cancel out. We briefly talked before break about the periodic table of elements and how we can read the information that we have there. So on the periodic table of elements, you should see a key towards the top that tells us what each of these numbers mean. So this number up here is the atomic number, and your atomic number is also the same as your number of protons. So make sure you're writing these notes down. This is our element symbol. So Na means sodium, which is our element name, and then finally we have the average atomic mass. In order to get our mass number, we round this number to the nearest whole number to estimate it, and we'll talk more about that. And then over here we see that the atomic number again equals protons or electrons if it's in a neutral atom. So for example, since I said the atomic number for sodium is 11, if it's neutral, it will have 11 protons and 11 electrons. Then our mass number equals the number of protons plus the number of neutrons. Or if we needed to figure out the number of neutrons, we could do the mass number minus the number of protons, which we will do quite often. If we look at the atomic masses on our periodic table of elements, so if you grab out a periodic table of elements, we might notice that most are not whole numbers such as 0, 1, 2, or 3. Why might this be? Pause the video, write down your predictions. So the reason why these are not whole numbers is because we're talking about the average atomic mass. So the different atoms actually have a different mass, but then we can take the average of the atomic mass, which then of course gives us a not a non-whole number. Next, we are going to label the atomic number and the number of protons, electrons, and neutrons for a neutral atom. So if I were to go through this, I would find carbon on my periodic table of elements, so this will be your cheat sheet. I see that it has an atomic number of 6, which would mean it also has the same number of protons. Since I said these are neutral, it also has 6 electrons. And then the neutrons, we said to figure out the number of neutrons, it would be my atomic mass, my average atomic mass, rounded to the nearest whole number, so the atomic mass number, minus how many protons I have, which is 6, which gives me 6 neutrons. Pause the video and fill out the rest of the chart by yourself, and we will go over these answers in class. Next class. Next, we're going to be talking about charged objects. So we can also have an atom that is positively charged or negatively charged, and again, those are called ions. So we have cations and anions. So positive objects mean they lose electrons. We cannot change the atomic number of a certain atom, so instead we can only change the number of electrons. So in order for something to become more positively charged, it loses electrons, and then if it were to become, so here we see it's losing electrons, so this is more positive than this one, which is helium. And then it would gain electrons if it's becoming more negatively charged. So this is my neutral helium atom. I know this because it has 2 protons, 2 electrons, 2 neutrons. This is more positively charged because it has more protons than electrons. And then here is more negatively charged. It has gained electrons. And like we just said, objects cannot gain or lose protons. Next, we're going to talk about something called the Nuclide symbol. So sometimes we may write these Nuclide symbols to help just tell someone the information that we have here. So it's really important that you have this written down. You have all these numbers written down. So pause the video and write these down. We have the element symbol, we have the mass number, the atomic number, and the electrical charge. And sometimes you're going to have to figure those out by yourself, so I've included the equations to help you figure those out as well. So I'm going to give you guys some time to practice. So I'll do this first one for you once again. So our number of protons here is 5. And then I kind of like waiting until the end, but to do my number of neutrons, so I might go back to that. But since there is nothing there, the charge is 0. And since we don't have a charge, the number of electrons and protons are the same, so it is 5. And then my neutrons would be 11 minus 5, because 11 is my mass number, so it is 6 neutrons. I'll go through this next one with you guys as well. So after you've done it, continue on. But this one does have a charge. So again, my protons are 8, because that's the atomic number. My neutrons are 16 minus 8, so that is 8. My charge this time is minus 2, which means I have gained electrons. I have more electrons than protons. How many have I gained? I've gained 2. So 8 plus 2 is 10. Finish these next 2 boxes for practice, and then we'll go over them in class. You will have time to work through these next practice problems right now, and then there will be another video for you to continue on with our second part of your notes.